Suppose you go to the emergency room with a bad cold. You get there and someone's being treated for pneumonia. So you sit around and you're waiting for them to finish, and while you're waiting, someone else comes in and they've been in a serious car accident and they have various severe injuries. Who do you think is going to get treatment first, you or the person who is in the car accident? Well, the answer is clear, the person in the car accident. And that's an example of something called a priority queue. Priority queue is a data structure that stores things that have priorities, right? You go in the emergency room, you have a low priority. The person in the car accident has a high priority. They're the first person taken out of the queue. That's the motivation for priority queues. Now, a priority queue is a data structure, and it has the following operations. It has insert, right? So someone arrives at the emergency room, they get added to the queue. It has a max operation, and that's going to return the element with the largest priority, or the largest, or the maximum priority. And then we're going to have a function called extract max, which removes the element with the largest max priority. Okay, I'm going to give some pseudocode that'll look a lot like C for the insert function. And underneath, what we're going to use is a heap. Now, in a max heap, if you look at the root node, you know by the max heap property that the root node has the largest value, or the largest priority. And we're going to use that fact. Okay, so this is pseudocode for insert. We're going to insert an element, E. And a couple of, one interesting or important thing is that this is a zero-based index. Not like the book. The book is one-based, this is zero-based. Okay. So I'm going to implement or insert an element. First thing I'll do is increment the heap size. Then I will heap size -1. So this adds E to the end. Now the data structure is no longer a heap now. Oh, no, probably not a heap anymore, because the element E probably does not obey the max heap property. So then, while I is greater than 0, we're going to swap I. So let's say I here. Sorry, I is heap size -1. So I is where we inserted the element E. So we're going to swap I with the parent of I. If the parent of I is smaller. And then we set I to be the parent of I, and we iterate until we reach the root. And that's it, we're done. We're just going to, you could say we're going to bubble that element up to its proper place in the heap, and we've inserted the element. Now, here we're iterating until we reach the root. And you're going to implement this in a project, but take care here, because many implementations of parent at index 0 will return 0, and that would lead to an infinite loop. So just be careful. You can handle it easily, taking extra precautions, but just be aware of that. Now, extract max. Now the max function simply returns the root, so that's straightforward. Extract max is going to be a similar approach to heap sort, in that we're going to swap the root with the very last element and then we will max heapify the root. And then we can remove the root. So just like we did with heap sort. That's priority queues.